In this example, we're going to use the reaction-based library enumeration feature in StarDrop's Nova module to generate a library of virtual compounds. This will be based on predefined sets of reagents that will be used to generate products using well-known reactions. In StarDrop, open the project Reaction-based Library Enumeration by selecting Open from the File menu. The project contains two reagent datasets. The current dataset contains a set of anilines, and these have been categorized indicating whether they are available in-house. A chemical space shows the distribution of these in terms of their chemical similarities, and we can see that in-house reagents largely cover the space of available anilines. We're going to enumerate a library limiting the choice of anilines to those available in-house. Minimize the dashboard containing the chemical space and click on the Nova tab. Click on the Go button to start the Nova wizard. Choose Reaction-based Library Enumeration and click the Next button. The first step is to choose the reaction that you'd like to use. There are over 120 reactions available, and you can browse these either by their name or their general type. You will also see any reactions that you have created, along with any shared by your organisation in the list of generic reaction libraries. If you wish to use a reaction that's not in the list, then you can choose the Sketch option to display a reaction editor. We're going to use the Buchwald-Hartwig reaction, which you can find easily by starting to type its name into the search bar at the top. As you type, the list will contract to display only matching reactions. Type the letters BU into the search bar, and Buchwald-Hartwig will appear at the top and be selected. Click the Next button. We can now define the reagents that we wish to use in the reaction. On the next page of the wizard, you can see the chosen reaction displayed, and below it a series of tabs, one for each reagent in the reaction. For reagent group 1, select the aryl halides dataset. This dataset contains 101 reagents, but only 100 of them are suitable, as shown to the right. By default, the Display Suitable Reagents Only option is ticked. There is also an indication if there is more than one reactive site on any of the reagents. To the top left of each structure is an indicator showing the number of sites on that reagent that match the reaction. If you are only interested in general properties, then the first site option, Use one site, may be sufficient, but in more complex cases you may prefer to use none. In this case we will choose sites, which enables us to specify the regioselectivity. Tick the Choose Sites option and then click the Select button. Each of the reagents with more than one site that matches the reaction is shown on the left. Selecting any of these will display it to the right, enabling you to choose which site or sites you wish to take part in the reaction. Sites that have been selected will be blue and unselected sites grey. Clicking on a site will toggle it between being selected and unselected. Click on each reagent in turn on the left-hand side. Where the sites are all chloro, ensure that only the parachloro site is selected. Where there is a bromo, make sure that this is selected preferentially over chloro because it is more reactive. Having done this for each of the 5 reagents, click the OK button. In this set of reagents, while they are all aryl halides, there are also some substituents that may be undesirable. The first reagent contains an isocyanate, which is reactive to nucleophiles and therefore unlikely to survive the reaction. In addition, some of the other reagents contain aldehydes, which may be undesirable. We will therefore filter this reagent set before proceeding. In the Selection Criteria section on the right, click the Set button. Here we can define characteristics to look for in reagents we wish to keep. In this case, reagents that do not contain any of the functional groups we wish to avoid. From the drop-down list next to Structure, choose Contains None of. Click Select to choose the functional groups to avoid. The dialog provides a large number of predefined functional groups, and you can add your own to this list by importing them or sketching. In the oxygen functional groups, tick the box next to aldehyde. In the nitrogen functional groups, tick the box next to isocyanate, isothiocyanate, and then click the OK button. The Selection Criteria dialog will now show these groups to be avoided. Note that you can define multiple selection criteria based on any combination of the structure and properties of the reagents. Click the OK button to use the selection criteria we have defined. We now have 95 suitable reagents left in the set and can move on to reagent group 2. Click on the reagent group 2 tab and then from the dataset list choose anilines. For the anilines, we're going to specify selection criteria based upon in-house availability. In the Selection Criteria section on the right, click the Set button. From the drop-down menu on the left, choose In-house. tick the Yes option to indicate that we only wish to keep reagents that are available in-house. Click the OK button. There are 19 reagents with multiple sites, so for this set we'll avoid using these 19 reagents. Select the Use None option and then click the Next button. The control output page shows us that there will be 2,000 or so products generated using the reagents we have selected. With this being a small library, it's no problem to generate the complete set. However, it would be easy to specify reagent sets which, when combined, produce libraries with many thousands or even millions of products. In such a scenario, it may be useful to choose the Select Subset option, after which you can choose how to select the products based upon a property, diversity, or a score combining multiple properties to be optimized simultaneously. Click the Next button and then give the dataset a name. In this case, we've called it Library. By default, all data associated with reagents, as well as their structures, will be included in the new library. If you're generating a library with many thousands of products, then you might wish to untick the Include Reagent Structures in Enumerated Library option, because for large sets, the additional structures in every row may result in a significantly larger file size when you save your StarDrop project. Click the Finish button. While the library is being enumerated, StarDrop will provide a progress indicator within the Nova area. You can continue to use StarDrop while the enumeration takes place. When the process is finished, the new dataset will be displayed. Each product in the dataset is given an automatic ID based upon the combination of names of the reagents used. As you scroll across the dataset, for each product you will see all the properties from its associated reagents prefixed by RG1, RG2, etc. To prepare this dataset for synthesis, we will assign plate IDs to all the products. From the Dataset menu, choose Assign to Plate. The dialog that appears enables you to choose between a 96 and a 384 well plate. In addition, you can choose whether to fill the plate by row or by column. In this case, we will use the default options, so click the OK button. A new plate assignment column is added to the dataset. Each entry shows the plate number, the row indicated by a letter, and the column indicated by a number. All StarDrop's capabilities can be used to further analyse or visualise the resulting library, and you can export the dataset easily via the File menu as CSV or text file when you're ready to send the library for synthesis. For more examples of how to use StarDrop's other features, take a look in the tutorial section of the Optibrium community.